All right, good morning, everyone. Here we go. This is going to be our Unit 7 test review. This is all about trigonometry. And here we go. I'm just going to make page 1 right now, and then I'll probably make the other ones later. So on this front page, I only had you guys do 1, 2, 3, and 4. Numbers 5 and number 6 were from sections 7.6, which is what we skipped. So let's just do these real quick. So number 1, we have to find the measure of angle C. So now if we look at this triangle, right, we have angle A, and angle A, of course, is across from side A. All right. We have side C, and that is across from angle C. All right. So we're kind of making this crisscross pattern. We do not know angle C. All right, but we know 3 things and we need to find the 4th. So whenever we have this kind of situation, this puts us in the law of sines realm. So what we can do is we can go ahead and make an equation. We can say the sine of angle C, that is our unknown angle, the sine of angle C divided by 27, that is going to be equal to the sine of 115 divided by side A, which ends up being 49. All right, so now this is a proportion, and we solve proportions the same way that we've always done. We're going to go ahead and cross multiply. All right, so what we end up with is 49 times the sine of C. That equals 27 times the sine of 115. Now, you're tempted to go ahead and type this in your calculator and get some long decimal, okay? But when we get a long decimal, we end up rounding it. So let's just try to avoid doing that. So let's just kind of think about what we need to do. We are trying to solve for C. Now, before we can solve for C, we need to get the sine of C by itself. All right, so the only thing that's keeping the sine of C from being by itself is at 49. So what we can go ahead and do is just divide both sides by that 49. Right? Then we're going to end up with the sine of angle C. The sine of angle C is going to be equal to 27 times the sine of 115. Right? And then we can divide that whole thing by 49. All right. So what we can do from here is, if you want to, you can go ahead and type that into your calculator and get a really long decimal, right? And use that entire decimal. But before we do that, or well, you can do that. We just have to be careful. We're trying to get C by itself, right? C is an angle. And whenever you're looking for an angle, whenever you have the sine of C or even the cosine of C or tangent of C, whatever, to get the angle out of that sine, here's what we kind of do. We inverse sine both sides. All right, so this is kind of the inverse sine on both of them. So what we're left with is we're left with angle C equals the inverse sine of this entire thing, 27 times the regular sine of 115, all divided by 49. All right, and then from here, we have to use our calculator. Nobody knows what this is without a calculator. So what we're going to do is we're going to first inverse sine, and then on the top we have 27 times the regular sine of 115. Now from here, close this parenthesis, right? This closing parenthesis that I just typed in, kind of locks in that 115. So it's the sine of 115. Then we press the divide button. Then we're going to have our 49. And then we're going to have another closing parenthesis, because if you look at when we first typed it in, when you take the inverse sine, it automatically comes with an opening parenthesis. And then we have the regular sine that had another opening parenthesis, right? So if you have 2 opening parentheses, you have to have 2 closing parentheses. Right? Then we're just going to press enter. So our angle is 29.95 degrees, but we said when we have an angle, we're going to round to the nearest whole number, the nearest degree. So we're going to say C equals 30 degrees. All right, and that's number one, using the law of sines. Number two, kind of the opposite. We need to find AB, right? So AB is across from the 28-degree angle, and then the 17 is across from the 127-degree angle. So this is going to be another law of sines problem. Now, this is side length AB. If you want to, right, you can put a variable in here, right? This is across from angle C, so you could just call that side length C if you want to, or you could leave it as AB, as AB being that single variable, as segment AB. But in either case, the setup will be the same. So we are going to have the sine of 28 divided by the side that is across from the 28-degree angle, which in this case we called C. All right, that is equal to the sine of 127 divided by 17. All right, so just like last time, we're going to go ahead, cross multiply. So we have C times the sine of 127. That equals 17 times the sine of 28. All right, now again, we are solving for C. And the only thing that's keeping C from being by itself is the sine of 127. Now the difference, so we need to divide both sides by the sine of 127. And remember, the sine of 127 is just some decimal. You type that into your calculator, you get some decimal, right? So you can treat it like any other number, right? So what we end up with is C equals that whole mess we have on the right-hand side. So the difference between this problem and the last problem, if you look at number one, we were looking for an angle. But if you look at this problem, we are looking for a side length. All right, so after we do this step, we can just type this straight into our calculator. Since we were looking for a side length, we don't have to do that inverse sine thing like we did on the last problem. All right, so what we're going to have is 17 times the sine of 28. All right, and again, make sure you close that parenthesis, because if you do this, if you forget that parenthesis and you put the divide right here, right, you're going to have something like this. That is wrong. Okay, we need to close up that sign. We need to tell the calculator, hey, 28 is the angle. All right, we don't want to have anything else on the inside of that sine function. So close the parenthesis and then press the divide button. Then you're going to have the sine of 127. All right, and again, close up the parenthesis, press enter, and we have a side length. So we said, in the beginning of this chapter, we were going to round side lengths to the nearest thousandth. Okay, so this is going to be 9.993. All right, so there is our side length. All right, so it's really close to 10, but it's not 10. All right, do not call that side length of 10. Let's call it 9.993. All right, next one, we need to find side AC. All right, so now if you look at this one, this is not a law of sines problem, because a law of sines problem, we have to have angles and sides that are across from each other. So we have a 32-degree angle, but we don't, let's try that again. We have a 32-degree angle, but we don't have the side length that's across from it, right? We have a 30-centimeter side, but we don't have the angle that's across from it. And then we have a 17-centimeter side length, but we don't have that angle that's across from it. So if we were to try to do the law of sines on this problem, no matter how we set it up, we're going to have two variables. We're going to have two unknowns in the problem. So the law of sines would kind of fail us on this one. So we are looking for this side length. This is not a 90-degree triangle, so we are going to have to use the law of cosines. All right, so again, you can call it whatever letter you want, but we should be using, the letter that's across from that angle. So that's angle B. So opposite angle B is like lowercase b. So let's use the law of cosines, right? So we have all those formulas. But the way to think about it is we're going to have some number squared equals another number squared plus another number squared minus 2 times those numbers times the cosine of some angle. All right. Now, to kind of figure out what goes where, whatever angle we have is always going to be across from the side length that we're looking for. So we have the 32-degree angle. So the unknown, the thing we are trying to look for, is going to be across. It's going to be opposite from that that angle that we have. So we're going to have B is going to be by itself. Now the other two things are just the other sides that we have. All right, so we have 17, we have the 30. All right, so we're going to put that in both of these spots. All right, and these numbers are being multiplied, so I should have put them in parentheses. All right, and there we have it. That's our setup. Now, luckily with this one, right, everything that we have is on one side of the equation, right? These are all just numbers. There are no variables on the right-hand side of the equation. So we can just type this all straight into our calculator to spit out an answer. All right, so what we're going to have is we're going to have B squared equals, let's go back to the calculator. Nobody can do this in their head, so we got 17 squared. It's going to take a minute to type in the calculator, plus 30 squared minus 2. Let's see, here we go. 2 times 17 times 30 times the cosine, right? It's the log cosine, so use cosine function of 32 degrees. All right, so we got a big old number, right? 323.99. Now, that is B squared. So what we need to do is we need to square root this answer. So press the blue button in your calculator. That's your kind of your shift button, and then look for the x squared. Right, you do that, it'll bring up a square root. So instead of typing all of this into your calculator, press the second button again. Right, it brings up that little arrow here. And then down at the bottom of your calculator, you have the negative button. Right above it, it says A-N-S. All right, that A-N-S stands for the previous answer. So you're going to take the square root of the previous answer, right? So this 323.9909419, that's what the A-N-S is, right? So we know B is 17.9997. So if we round that to the nearest thousandth, we have to look at the 10,000ths place. So that's 7 rounds up the 9 to a 0. It's going to round the other 9 up to a 0. It's going to round the other 9 up to a 0, which is going to round it up to an 18. So our final answer here, B is equal to 18. All right. We got one more on page 1. We are looking for angle A. So this is an SSS triangle. So we have to use the law of cosines again. Just like on this one, I should have mentioned earlier, this is an SAS triangle. So that's another indication that we have to use the law of cosines. All right, so we're looking for angle A. Ooh, looking for angle A. So we are going to have 18.1 equals 8.5, 18.1 squared equals 8.5 squared plus 23.4 squared minus 2 times those same two numbers, 18.5 times 23.4 times the cosine of the angle that we are looking for, angle A. All right, so now the difference between this problem and the last one is that we cannot type this into our calculator because we don't know what A is, right? We can't just put an A in the calculator. The calculator doesn't know what that is. All right, so we're going to have to do a little bit of algebra on this problem. So first things first, I would go ahead and just get all of these numbers. 18.1 squared, that's 327.61. 327.61. All right, now what I'm going to do next is I'm going to put both of these in the calculator. So we're going to have 8.5 8.5 squared plus 23.4 squared, right, whatever that is, 619.81. All right, when somebody's going to do this on a test, all right, you do not put all of this in your calculator once. That will give you the wrong answer. I've said it 100 times, but this thing right here, right, that is attached to the cosine. So we cannot combine it with the 619. All right, we have to do a little bit of algebra before we get there. So I'm going to do this all in a different color. All right, so now let's go ahead and type this in. So -2 times 8.5 times 23.4. All right, and that is going to give us, hang on one second, give me like 5 more minutes. That's going to give us -397. 0.8, 397.8 times the cosine of A. All right, so now what you want to do is go ahead and subtract the 619 over. So you got 327.61 minus 619.81. It gives us -292. -292. I think it was a 2. Yeah, okay. That equals -397.8 times the cosine of A. All right. So now, all right, so how I got there is, I subtracted 619.81 on both sides. All right, so now divide both sides by the -397.8. All right, so we're going to have that fraction, -292.2 divided by -397.8 equals the cosine of A. All right, now keep in mind, we are looking for angle A. So we're not done. The last thing we have to do is we're going to have to inverse everything here. All right, so we're going to have the inverse cosine, right, of -292.2 divided by -397.8 equals angle A. All right, we're going to type that into our calculator. Now this number, every single time when you take an inverse on a sine or on a cosine, this fraction that you have in the middle, right, that needs to be between -1 and +1, right? If you just type in this fraction, the 292.2 divided by 397.8, right, that's a number that's between -1 and +1, which is what we want. If it's outside of that interval, you're going to get an error on your calculator. All right, so what we're going to do is I'm going to just take the inverse cosine of this fraction that we had. All right, so what you can do is you can also go up and you can just highlight this entire thing. If you press enter, right, it'll put that in your calculator for you, right? And then since it's a negative divided by a negative, those cancel out to positive, so it's okay that I just put positives on both of those. All right, so when we take the inverse cosine, we're going to have an angle of 42.7, which as a whole number is 43. So angle A equals 43 degrees. All right, and that's how we do the law of cosines. That was kind of one of the longer kinds of cosine problems there. All right, so that was page 1 of your review, and we'll see you guys on the next one.